Very good afternoon to one and all. I welcome you all for the next lecture of heat transfer. Please let me know whether my voice is audible and can you see my presentation? Great. So, in the last lecture, we have discussed about the effectiveness for the parallel flow. Okay. And at the last, we have got this particular equation for the effectiveness of a parallel flow. That is nothing but effectiveness is equal to 1 minus exponential of inside the square bracket minus NTU inside the bracket 1 plus r bracket complete square bracket complete whole divided by 1 plus r. So here we have to remember that NTU is nothing but NTU is nothing but the ratio of product of overall heat transfer coefficient multiply by area divided by C minimum. Okay, UA divided by C minimum, that is nothing but the NTU. And second thing is nothing but the ratio of heat capacities. Okay, capacity ratio C minimum to C max. Okay, C minimum to C max, this particular ratio is represented by R, or it is having the symbol of R, so that will be called as a capacity ratio. Okay, so in this lecture we try to understand the effectiveness for the counter flow. Okay, effectiveness for the counter flow. So as we have discussed for the LMTD method. Okay, so the counter flow is nothing but the fluids are flowing in a opposite direction. Okay, fluids are flowing in opposite direction. Okay, so here you can say that where the hot fluid entered in the heat exchanger, on that side the cold fluid will exit from that side of a heat exchanger, whereas the hot fluid entry is there on that side. Hot fluid exit is there on that side, cold fluid entry should be there. Okay, so that is nothing but the counter flow heat exchanger. So in this case we will get theta 1 as th1 minus tc2. Okay, theta 1 as th1 minus tc2 and theta 2 as th2 minus tc1, th2 minus tc1. We have to remember this part. Okay, and you can see that if you observe this particular diagram, then you come to know that this is the positive x direction. Okay, this is the positive x direction, and in positive x direction both the fluid temperatures are going to decrease. Okay, both the fluid temperatures are going to decrease, no matter that the hot fluid temperature is decreasing only, but the cold fluid is in cold fluid temperature is increasing in opposite direction, but it is increasing in a negative x direction. That is nothing but negative x direction. Okay, and in positive x direction the cold fluid temperature is also decreasing in case of a counter flow heat exchanger. Now for the analysis purpose, in as similar concept we are taking as that of a LMTD method. So for the analysis purpose we are considering one small area. Okay, having the area of a dA out of the total heat exchanger area. Okay, and the entry temperatures for the hot fluid and the cold fluid for this area are th and tc. Okay, th and tc, and the initial temperature difference will be represented as theta. So theta is equal to th minus tc. Okay, whereas as the hot fluid flowing over this area, or the elementary area which we have considered for the observation purpose, the hot fluid temperature goes on decreasing. Okay, and the total temperature difference between the inlet temperature and outlet temperature is dt suffix h. Okay, whereas the cold fluid temperature is increased in opposite direction. Cold fluid temperature is increased in opposite direction. So the increasing temperature of a cold fluid we have to consider as a dtc. Okay, we have to consider as a dtc. So the similar fashion we are going to consider one elementary area as that of uh, LMTD, one elementary area, that is DA area we have considered, and the heat exchange over this area, elementary area DA, will be considered as a DQ. Okay, and that will be equal to u multiplied by dA multiplied by th minus tc, and that will be also written as u multiplied by dA multiplied by theta. Okay, now we know that as the fluid is passing over that elementary area, the cold fluid temperature goes on is increased by dTc amount, and hot fluid temperature decreased by dTh amount. Okay, so we can apply the energy balance equation, that is nothing but heat lost by the hot fluid, that much amount of heat will be gained by the cold fluid. Okay, that much amount of heat will be gained by the cold fluid. So by considering this energy balance equation, we can write that dq is equal to minus m dot h multiplied by cph multiplied by dth. Okay, and which will be equal to minus m dot c multiplied by cpc multiplied by dtc. Now in case of a parallel flow, only the heat loss by the hot fluid, we have considered the negative sign. Okay, we have considered the negative sign. But in this case, in case of a counterflow heat exchanger, both, that is heat lost by the hot fluid and heat gained by the cold fluid, both the values or both the equations are having negative sign. Both the equations are having negative sign. So here you can see that minus sign is there, and here also minus sign. Why it should we have to provide the minus sign? As early in the start of the lecture only, I have discussed that the both the lines or both the temperatures are decreasing in a positive x direction. In case of a parallel flow heat exchanger, only hot fluid temperature is decreasing in positive x direction, but here you can see that the cold fluid temperature is increasing in negative x direction. Okay, यहाँ से ऐसे ऊपर जा रहा है, बट हम फ्लो की डायरेक्शन और एरिया की डायरेक्शन क्या ले रहे हैं, इधर से इधर ले रहे हैं. So this is our positive x direction. So in this direction, the cold fluid temperature, we can see that it is decreased one, or we can say that the next temperature of a cold fluid is lesser than the initial temperature. Next temperature of a cold fluid is lesser than the initial temperature. So that we have to consider this both the heat transfers or heat exchange that will be negative. Okay, both the heat lost by hot fluid and heat gained by cold fluid, both are having the negative sign. Okay, then further from this particular equation we can write dTh, which will be equal to minus dq divided by m dot h multiplied by cph, and which will be equal to minus dq divided by c suffix h. Okay, so from this first part, and from the second part we can write the dtc. dq is equal to minus m dot c multiplied by cpc multiplied by dtc. So from this second part we can write dtc is equal to minus dq divided by m dot c multiplied by cpc is equal to minus dq divided by c suffix a, and we know that c suffix h is nothing but m dot h multiplied by cph, that is nothing but heat capacity of a hot fluid, and c suffix c is nothing but m dot c multiplied by cpc, that is nothing but heat capacity of a cold fluid. So similar, the same routine procedure we have to follow as that of a parallel flow heat exchanger, that we have considered the theta, and theta is equal to th minus tc. And when you differentiate, then you will get the d theta is equal to dth minus dtc, which will be equal to minus dq divided by ch, and minus minus will become plus, therefore plus dq divided by c suffix c. So here if you take the dq minus dq common out of the bracket from the right hand side, then you will get theta is equal to minus dq inside the bracket 1 upon ch minus 1 upon c suffix c. And from equation number a, we know that d theta is nothing but u multiply by dA multiply by theta, where theta is nothing but th minus tc. Okay, so we have to substitute this dq equation in this particular d theta equation. So we will get d theta as d theta is equal to minus u multiply by dA multiply by theta inside bracket 1 upon ch minus 1 upon c suffix c. Okay, now here if you take the theta on this side, so the equation will become d theta divided by theta, which will be equal to minus u multiplied by dA inside bracket 1 upon ch minus 1 upon c suffix c. Once again, we have to integrate this. Now this equation we will get for the particular considered elementary area. Now we have to consider for total area, okay, total area of that heat exchanger, and the total temperature difference we have to consider. So therefore we have to integrate the equation with respect to limits, and the limits for the theta are theta 1 to theta 2 at the inlet, or the at one side the theta is become theta 1, and on another side theta becomes theta 2, whereas the area at the inlet on one side we have to consider as a 0, and at the another end or at the outlet we have to consider the area as a. So after providing the integration and limits, the equation will become the integration of d theta divided by theta with the limits theta 1 to theta 2, and integration of, with the limit 0 to a of minus u multiplied by dA inside bracket 1 upon ch minus 1 upon c suffix c. Okay, then the integration of 1 upon theta is nothing but ln of theta, and we have to provide the limit theta 1 to theta 2. Then integration of only dA is only a, and we have to provide the limits 0 to a. Okay, then put up the limits, upper limit minus lower limit, then we will get ln of theta 2 minus ln of theta 1, which will be equal to minus u multiplied by a inside bracket 1 upon ch minus 1 upon c suffix c. Okay, apply logarithmic rule for ln of theta 2 minus ln of theta 1, that we can write as ln of theta 2 divided by theta 1, and which will be equal to minus u multiplied by a inside bracket 1 upon ch minus 1 upon c suffix c. Now here, up to this we have discussed in LMTD method also. Okay, in LMTD method also. Now further part is most important, as we are discussing about the effectiveness for the counter flow heat exchanger. Now what we have done for this equation, we have remove out this logarithmic term from this side, and if you remove out the logarithmic term from the left hand side, you have to provide the exponential term on the right hand side. So once you remove this term, the logarithmic term from the left hand side, so you have to provide the exponential term for this particular right hand side. Okay, so that we have done over here, and we know that in case of a counter flow heat exchanger, theta 2 is nothing but th2 minus tc1, whereas theta 1 is nothing but th1 minus tc2, th1 minus tc2, and that will be equal to exponential of minus u multiplied by a multiplied by 1 upon ch minus 1 upon c suffix c. That will be considered as a equation number 1. Okay, so already equation 1, 2, 3 are considered. So we will consider equation number 4. Okay, equation number 4. Okay, now further we know that the effectiveness formula. Okay, effectiveness equations, we know that effectiveness is equal to c suffix h inside bracket th1 minus th2 whole divided by c minimum inside bracket th1 minus tc1, and that will be equal to c suffix c inside bracket tc2 minus tc1 whole divided by c minimum inside bracket th1 minus tc1. Okay, so from this first part of equation we can write the ch inside bracket th1 minus th2, that will be equal to eta, that is effectiveness multiplied by c minimum multiplied by th1 minus tc1. Okay, and from this equation, if you shift ch on this side, c suffix h on this side, it will be on the denominator side, and then if you shift the th1 on this side, it will be the minus th1 plus this particular right hand side. But if once you shift this negative sign on this side, then the signs will be changed, and we will get th2 as th1 minus effectiveness multiplied by c minimum inside bracket th1 minus tc1 whole divided by c suffix h. Okay, similarly if you consider the second part of the equation, that is eta is equal to c suffix c multiplied by tc2 minus tc1 whole divided by c minimum inside bracket th1 minus tc2. If you consider this part of equation, then we can get the equation as c suffix c multiplied by inside bracket tc2 minus tc1, which will be equal to effectiveness inside multiplied by c minimum inside bracket th1 minus tc1. Okay, and from this equation we will get tc2. Okay, So once you shift this C suffix C on this side, it will be on the denominator side. Then we want TC2 only, and if you shift this TC1 on this minus TC1 on this side, so it will become plus TC1. So in this case, we will get TC1 as TC2 as TC2 is equal to TC1 plus effectiveness multiplied by C minimum inside bracket TH1 minus TC1 whole divided by C suffix C. Okay. Now TH2 and TC2 equations, we have got these two equations, and we have to put up these two equations in equation number 4. Okay, in equation number 4. So where is the equation number 4? No, so this is the equation number 4. Okay, TH2 minus TC1 divided by TH1 minus TC2. Now in this equation, instead of TH2 and TC2, whatever the values or whatever the equations we have determined from the effectiveness equation, so that we have to put up in that equation number 4. Okay, so I have put up this equation TC2 and TH2 values in this equation. So TH1 TH2 is nothing but TH1 minus effectiveness multiplied by C minimum inside bracket TH1 minus TC1 divided by C suffix H and minus TC1. Okay, and then on the denominator side, it is TH1 minus TC2. Okay, TH1 minus TC2. Okay, so on the denominator, it will become TH1 minus TC2 is nothing but TC1 plus, but here we are having TH1 minus TC2, so minus sign we have to provide, so all the signs will be changed for the TC2 value. So we will get TH1 minus TC1 minus effectiveness inside multiplied by C minimum inside bracket TH1 minus TC1 whole divided by C suffix C. Okay, and that will be equal to exponential of bracket inside bracket minus U multiplied by A multiplied by 1 upon CH multiplied by 1 upon minus 1 upon C suffix C, bracket complete, square bracket complete. Okay, so from this equation, from the denominator side, okay, from the denominator side, so TH1 is there and TC1 is there. Also from the numerator side, TH1 is there and TC1 is there. So we can combine this TH1 TC1 in one bracket. Okay, and we can form one term. Okay, and from the denominator also TH1 minus TC1 is there, so we can form one term for this TH1 minus TC1. Now we are having two terms in the numerator side and we are having two terms in the denominator side, and in both the terms TH1 minus TC1, TH1 minus TC1 and TH1 minus TC1, and this TH1 minus TC1 is common. Okay, so we can take out this common out of the bracket and we can cancel it. Okay, because in the numerator side also TH1 minus TC1 is there, and on the denominator side also TH1 minus TC1 is there, so we can take common and we can cancel it. Okay, okay, or we can divide it. Okay, so in this fashion TH1 minus TC1 we have combined in one bracket, so that we will get two terms only in the numerator and two terms in the denominator. So this TH1 minus TC1 and this TH1 minus TC1 we have to take as a common. Okay, and from the from the denominator side, TH1 minus TC1 and TH1 minus TC1 we have to take common, and the numerator TH1 minus TC1 and denominator TH1 minus TC1 will be cancelled or divided. Okay, so further we will get the equation as 1 minus effectiveness inside bracket C minimum divided by CH, and on the denominator side we will get 1 minus effectiveness multiplied by C minimum divided by C suffix C, and that will be equal to exponential of in a square bracket minus U multiplied by A inside bracket 1 upon CH minus 1 upon C. Okay, so once again we have to consider some of the things. Okay, so first of all we will consider, okay, so this equation will be solved by considering both the things. If you consider C suffix C is equal to C minimum and C suffix H as a C max, and R is equal to C minimum divided by C max. Okay, so then also you will get the same formulas. Okay, and if you consider the CH is equal to C max, CH is equal to C minimum, and CC is equal to C max, so in that case also you will get the same formula. So one of the consideration is sufficient to derive the equation, okay, because the equation is too much lengthy. So derivation is too much lengthy. So one of the case we will discuss, and we will consider the same thing for the another case also. So case is here, we are considering C suffix C is equal to C minimum and C suffix H is equal to C max, and we know that the capacity ratio, that is R, is nothing but C minimum divided by C max, okay. So wherever there is a C suffix C is there in this particular equation, at that point or at that particular location, we are replacing C suffix C by C minimum, and wherever there is a C suffix H in this particular equation, at that location we are replacing C suffix H by C max, okay. So after doing that particular action, we'll get the equation as 1 minus effectiveness multiplied by C minimum divided by C max. Also in the denominator side, 1 minus effectiveness C minimum divided by C minimum, okay. So that will be cancelled, okay, and which will be equal to exponential of inside the square bracket minus U multiply by A multiply by inside bracket 1 upon C max minus 1 upon C minimum, bracket complete, square bracket complete, okay. So we know that C minimum divided by C max is nothing but R, so we can directly take C minimum divided by C max as R, and in the denominator side, C minimum divided by C minimum will be cancelled, okay. And on this side, so on the right side, if you take 1 upon C minimum as common, okay, out of this particular bracket, so then you'll get inside bracket as C minimum divided by C max minus 1, okay. So final equation will become 1 minus effectiveness multiplied by R whole divided by 1 minus effectiveness, that will be equal to exponential inside the square bracket minus U multiply by A multiply by 1 upon C minimum inside the bracket C minimum divided by C max minus 1. Now once again over here C minimum divided by C max is there, so we can replace this by R, that is nothing but capacity ratio. So we will get the equation as 1 minus effectiveness R multiplied by R divided by 1 minus effectiveness, that will be equal to exponential of, now here we know that UA divided by C minimum is nothing but NTU, that is number of transfer units. So we can replace this U multiply by A divided by C minimum by NTU, okay, by NTU. So we'll get the equation as 1 minus effectiveness R multiply by R whole divided by 1 minus effectiveness, that will be equal to exponential of inside bracket minus NTU inside the bracket R minus 1 bracket complete, square bracket complete, okay. So then if you transfer this 1 minus R on this side, so that will be the multiplication with the exponential term, okay. So we will get the 1 minus effectiveness multiplied by R is equal to exponential term multiplied by 1 minus effective, okay. Then if you multiply, okay, if you multiply inside the bracket with this particular exponential term, then we will get 1 minus effectiveness R, which will be equal to exponential of exponential term minus effectiveness, because here exponential term multiply by 1, that will be only exponential term, and if you multiply exponential term with effectiveness, then it will be effectiveness multiplied by exponential term, okay. So we will get 1 minus effectiveness R equal to exponential term, exponential inside the bracket minus NTU multiplied by R minus 1 minus effectiveness multiplied by exponential of inside bracket minus NTU inside bracket R minus 1 bracket complete, square bracket complete, okay. Then what we do, we want the equation in the form of effectiveness, okay. So that will combine all the effectiveness terms, okay, or we will take all the effectiveness terms, or in which term the effectiveness term is present, okay. So that all the terms we will take on one side, and non effectiveness term, or we can say that the term which does not contain the effectiveness term, that we will take on one side, okay. So on the left side we have taken all the non effectiveness term, okay, which does not contain effectiveness term. So we will take this if exponential minus inside bracket minus NTU inside bracket R minus 1 bracket complete, square bracket complete. This particular term we have shifted on the right hand side, okay, and this effectiveness multiplied by R, that term we have shifted on the left hand side, okay, vice versa, okay. So Here we will get 1 minus exponential inside bracket minus NTU multiply by inside bracket R minus 1, which will be equal to effectiveness multiply by R minus effectiveness multiply by exponential of inside bracket minus NTU multiply by inside bracket R minus 1 bracket complete square bracket complete. Okay. So from this side, we can take now effectiveness common. Okay. From the right hand side, we can take the effectiveness common. So we'll get the equation as 1 minus. Now, once again, we want this particular term r minus 1. Okay, r value is lesser than 1, so we should not take r minus 1. So we want 1 minus r. Okay, so for that reason, we can take minus common out of this particular bracket. Okay, and we have to provide this outside the bracket. Okay, outside the square bracket. Okay, outside the square bracket, so that will become exponential of minus of that particular bracket, x1 minus exponential multiply by minus of bracket. Okay, so similarly on this side also we are doing the same thing, exponential of a minus of a bracket. Okay, minus of a bracket. Okay, and the 1 r minus 1 will be converted as 1 minus r. Okay, by taking the minus sign common outside the bracket. Okay, so if you transfer this particular term on the another side, then we will get the equation in the form of effectiveness. Okay, effectiveness is equal to 1 minus exponential of minus of this particular bracket NTU minus NTU inside bracket 1 minus r and whole divided by r minus exponential of minus of a bracket. So inside the bracket minus NTU multiply by 1 minus r bracket complete square bracket complete. Now exponential of minus of a bracket is nothing but 1 upon exponential. Okay, exponential of minus of a bracket, that is nothing but e raised exponential of minus x is nothing but e raised to minus x. Okay, e raised to minus x, and if you want to convert that in a positive sign, or then we have to transfer it to the denominator side. Okay, then if you want to convert e raised to minus x, okay, you want to write e raised to minus x, then it can be written as 1 upon e raised to x. Okay, 1 upon e raised to x. So similarly here our term is exponential of minus of this particular bracket, and in the denominator side also exponential of minus of this particular bracket. So we can write instead of that 1 divided by exponential of, and we have removed out the minus sign from here, 1 divided by exponential of bracket, and also in the denominator side also 1 divided by exponential of this particular bracket. Okay, so that your negative sign will be removed out here. Now then do the cross multiplication. So exponential term multiply by 1, so that will be the exponential term minus 1 that we have written over here, and exponential term multiply by r, so that will be r multiplied by exponential, and minus 1 will be this. So denominator will be r multiplied by exponential of a bracket minus 1. Okay, then you will get you can take the negative sign common from here. Okay, from the numerator side and denominator side. Okay, if you take the negative signs common, then the signs will be changed. So minus 1 will become plus 1, and this plus term will become minus term. Okay, from the denominator side also, if you take this negative sign common, then minus 1 will become plus 1, and plus this particular term will become minus. So then we will get the effectiveness as effectiveness is equal to 1 minus exponential of inside the bracket minus into multiply by 1 minus r bracket complete square bracket complete whole divided by 1 minus r multiply by exponential of inside bracket minus into multiply by 1 minus r bracket complete square bracket complete. So that will be the final equation for the effectiveness of counter flow heat exchanger. That will be your final equation for the effectiveness of a counter flow. Okay, so that I have explained how to derive the equation. Okay, so it is also an important one, how to derivation, how that particular equation come from the diagram. So that is also important one. Okay, so you can draw this diagram first of all. Effectiveness for counter flow. Effectiveness for counter flow. Draw the diagram properly. Okay. Provide these arrows to the diagram. Okay. Opposite directions you have to show. So that will represent that the type of heat exchanger is counterflow. Okay. The counterflow heat exchanger is there. So arrow direction is the important one in this diagram. Provide all the appropriate nomenclature. Have you drawn the diagram? So you can write. Let us consider. Let us consider. Write down. Let us consider. Let us consider an elementary area. Let us consider an elementary area dA. Let us consider an elementary area dA of the heat exchanger. Of the heat exchanger. Full stop. Full stop. The rate of flow of heat. The rate of flow of heat through this elementary area. The rate of flow of heat through this elementary area is given by is given by the rate of flow of heat through this elementary area is given by, okay, so dq is equal to u multiply by dA multiply by th minus tc. Dq is equal to u multiply by dA multiply by th minus tc, that will be equal to u multiply by dA multiply by theta, where theta is nothing but th minus tc. So consider this equation number A. Equation number A. Okay. Then next, as a result, as a result of heat transfer, as a result of heat transfer, as a result of heat transfer, dq, as a result of heat transfer dq through the area dA, as a result of heat transfer dq through the area dA, the hot fluid is cooled. The hot fluid is cooled. The hot fluid is cooled by dt suffix h. The hot fluid is cooled by dt suffix h, whereas 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 the cold fluid is heated up, whereas the cold fluid is heated up by by dt suffix c. The cold fluid is heated up by dt suffix c, dt suffix c. Therefore, we can write the energy balance equation as dq is equal to minus m dot h multiplied by cph multiplied by dt suffix h. That will be equal to minus m dot c multiplied by cpc multiplied by dt suffix c, and the equation number is 1. Okay, then from equation number 1 we can write dt suffix h will be equal to minus dq divided by m dot h multiplied by cph, and that will be equal to minus dq divided by c suffix h. We have to consider this equation as equation number 2, and dt suffix c will be equal to minus dq divided by m dot c multiplied by cpc, and that will be equal to minus dq divided by c suffix c. Okay, and we have to consider this equation as equation number 3. Okay, where this ch is m dot h multiplied by cph, and that will be equal to heat capacity of hot fluid, and c suffix c is m dot c multiplied by cpc, and it is equal to heat capacity of cold fluid. Okay, further we have to consider theta is equal to th minus tc, and therefore if you differentiate this theta, then it will be equal to d theta, and th minus tc will become dth minus dtc. Okay, and we know that dth minus dtc, okay, and it is equal to minus dq divided by c suffix h plus dq divided by c suffix c. Then if you take the common minus dq, then d theta will be equal to minus dq inside bracket 1 upon ch minus 1 upon c suffix c. And from equation A, we know dq is equal to u multiplied by dA multiplied by theta, where theta is nothing but th minus tc. Okay, then put up the dq value, then d theta is equal to minus u multiplied by dA multiplied by theta inside bracket 1 upon ch minus 1 upon c suffix c. And if you take this theta on another side, okay, therefore it will become d theta divided by theta, which will be equal to minus u multiplied by dA inside bracket 1 upon ch minus 1 upon c suffix c. Okay. Further, we have to integrate this equation. Now integrate between inlet and outlet condition. That is when A is equal to 0 and when A is equal to capital A. Okay. So integration of d theta divided by theta with the limit theta 1 to theta 2 and integration with the limits 0 to A for minus u multiplied by dA inside bracket 1 upon ch minus 1 upon c suffix c. Okay. Then integration of 1 upon theta is ln of theta and integration of dA is A. Provide their upper and lower limits theta 1 to theta 2 and 0 to A. Okay, further the limits we have to apply ln of theta 2 minus theta 1 and minus u multiply by a multiply by 1 upon ch minus 1 upon c suffix c. Okay, then apply the logarithmic rule. Then we will get ln of theta 2 divided by theta 1 will be equal to minus u multiplied by a inside bracket 1 upon ch minus 1 upon c suffix c. Okay, and we know that in case of a counter flow heat exchanger, theta 2 is nothing but th2 minus tc1 and theta 1 is nothing but th1 minus tc2. Okay, so shift this or remove this logarithmic term on the left hand side, so we need to provide the exponential term on the right hand side. So equation will become th2 minus tc1 whole divided by th1 minus tc2 will be equal to exponential of bracket minus u multiply by a multiply by 1 upon ch minus 1 upon c suffix c, bracket complete, square bracket complete, and give this equation number 4. Then as we know, effectiveness, okay, effectiveness is equal to this particular equation. Okay, and from that equation we have derived the th2 and tc2. Okay, so you can write these equations directly from the screen. Okay, over. Further, we have to put up the TC2 and TH2 values in equation number 4. Okay, so you can write, you just replace TC2 and TH2 values in equation number 4, and you can write this equation. Over. So further, we have taken th1 and minus tc1 on one bracket. Okay, one bracket. In this particular step, we have considered th1 and tc1 in one bracket, and in the denominator and numerator side. Okay, and that will be cancelled. Okay, because in the numerator side also, in both the terms, th1 minus tc1 is present, and on the denominator side also, in both the terms, th1 minus tc1 is present. So we can cancel this directly. Okay. Okay, so further, after cancellation of th1 minus tc1 from the numerator and denominator side, we will get 1 minus effectiveness multiplied by c minimum divided by ch, whole divided by 1 minus effectiveness multiplied by c minimum divided by c suffix c, and that will be equal to exponential of minus u multiplied by area inside bracket 1 upon ch minus 1 upon c suffix c, bracket complete, square bracket complete. Okay. And further, we have to consider c suffix c is equal to c minimum, comma c suffix h is equal to c max, comma r is equal to c minimum divided by c max. Okay, you can consider vice versa also, ch is equal to c minimum also, and cc is equal to c max also. Okay, but you will get the same equation only, and put up wherever there is cc, put up c minimum, and wherever there is c suffix h, put up c max. and here C minimum divided by C max is nothing but R. C minimum divided by C minimum will be cancelled, and from this side 1 upon C minimum, from this particular bracket 1 upon C minimum we have taken common. Okay, so we will get the equation 1 minus effectiveness R whole divided by 1 minus effectiveness, which will be equal to exponential of a bracket inside bracket minus U multiply by A multiply by 1 upon C minimum in the bracket C minimum divided by C max minus 1 bracket complete square bracket complete. Once again here C minimum divided by C max is nothing but R. So the equation will become 1 minus effectiveness R divided by 1 minus effectiveness will be equal to exponential of minus NTU inside bracket R minus 1. Okay, R minus 1. So this 1 minus effectiveness from the denominator side will be transferred on the right hand side. So it will be multiplied with the exponential term. Then we will get 1 minus effectiveness R equal to exponential term multiplied by 1 minus R, 1 minus effectiveness. Okay, then further we have multiply this exponential term inside the bracket. Okay, so multiply with 1 we'll get the same exponential term, and multiply with the effectiveness, so we will get the effectiveness multiplied by exponential term. Okay, then further we have taken effectiveness terms on one side so that we can take effectiveness as a common. Okay, and the terms which does not contain effectiveness term, that will be considered on another side. So we'll get 1 minus exponential inside bracket minus NTU inside bracket R minus 1 bracket complete square bracket complete is equal to effectiveness multiplied by R minus effectiveness multiplied by exponential of inside square bracket minus NTU inside the bracket R minus 1 bracket complete square bracket complete. Over. So further, what we have done, we have converted this R minus 1 into 1 minus R. To convert this R minus 1 into 1 minus R, we required to take negative sign common out of the bracket, and that common negative sign we have taken outside this square bracket. Okay, outside this square bracket. So we will get 1 minus exponential of minus of bracket. Okay, inside the square bracket minus NTU inside the bracket 1 minus R. Okay, bracket complete square bracket complete. Here also we have done the same. Here we have taken the effectiveness common out of the terms. Okay, and inside bracket R minus exponential of minus of bracket. Okay, we have taken minus sign common over here, minus NTU inside bracket 1 minus R. Okay, R minus 1 will be converted into 1 minus R. Okay, and then we'll get the effectiveness equation as 1 minus exponential of minus of bracket inside bracket minus NTU multiply by 1 minus r bracket complete square bracket complete whole divided by r minus exponential of minus inside the bracket minus NTU inside the bracket 1 minus r bracket complete square bracket complete and once again the bracket complete. Okay, then exponential of minus x, that is e raised to minus x, that will become 1 upon e raised to x. Okay, so in a similar fashion we have converted exponential of minus bracket as 1 minus 1 upon exponential of bracket. Okay, over. So further we will get, after cross multiplication we will get exponential of minus NTU if you do the cross multiplication to make the base same, but in the numerator also, in the numerator also base is exponential of minus NTU 1 minus r, and in the denominator also the base is exponential multiplied by minus NTU multiplied by 1 minus r. So that will be cancelled. Okay, and we will get the equation as effectiveness is equal to exponential of inside bracket minus NTU inside bracket 1 minus r bracket complete square bracket complete minus 1 whole divided by r multiplied by exponential of inside the bracket minus NTU once again inside bracket 1 minus r bracket complete square bracket complete 1 minus r. Okay, now from the numerator also we have taken the negative sign common, and from the denominator also we have taken the negative sign common. So negative minus 1 divided by minus 1, that will be plus 1, and if you are taking the negative sign commons, then minus 1 will become the plus 1. Okay, and this exponential positive exponential uh, will become negative exponential. Okay, so we will get the equation as effectiveness is equal to 1 minus exponential of minus NTU inside bracket 1 minus r bracket complete square bracket complete whole divided by 1 minus r exponential of inside bracket minus NTU inside bracket 1 minus r bracket complete square bracket complete. Okay, so this is the final equation we required for the counter flow heat exchanger, effectiveness counter flow heat exchanger. Okay, effectiveness of counter flow heat exchanger. Okay, note down all the points. Okay, because the derivations are important one. The Some problems are solved on the basis of a derivation only. Okay, so some of the clues you get to solve the problem through these derivations. And the two equation for effectiveness of parallel flow and effectiveness of counter flow, these are important equations. Okay, okay, I think tomorrow we are having HMT paper. You are having HMT paper, so this chapter number second, fourth, fifth, and this one, sixth. So these four chapters will be there for your ISC two. Okay, and the focus will be on more problems. Okay, problem on heat exchanger, problem on extended surfaces, then theory on convection, one theory on convection, then one problem or one derivation on convection, and theory on uh, boiling and condensation. Okay, theory on boiling and condensation. So that will be the format. One problem on heat exchanger. Okay, out of two, there are two methods for the problem. One is LMTD and one is exponential method. Any of the method will be there for the problem. But one is the most. Uh, I will focus on the problems on LMTD one, on this heat exchanger job. Okay. Then problem on extended surfaces. Then theory on condensation and boiling, and theory and problem on, or theory and derivation on convection. Okay, so in this fashion, the paper will be there. Tomorrow's paper will be there, and all the data. Okay, required data I've shared in a study material. I think only heat exchanger uh, data is not provided over there, and today I will provide that also. Okay, after this lecture, I will upload heat exchanger notes on our study material. Okay, please refer that study material if you are in any doubt. Please refer the YouTube lectures. YouTube lectures are also uploaded there. Okay. Okay. Is there any doubt, any question? So tomorrow we will take the two problems on this effectiveness method, and one point is only remaining about this chapter, that is nothing but heat pipe. Okay, heat pipe, heat exchangers. So that point I will cover. I will try to cover in the tomorrow's lecture only, and the chapter will be over tomorrow itself. If I get some time, then the chapter will complete tomorrow itself, and after tomorrow we will move ahead for the next chapter. Also, we have to complete the um, practicals, because you are having oral on the basis of practicals. Okay, uh, normally it is a POE, means practical oral examination. If your college, if you if you are in the college, then you have to perform that practicals. Okay, in the laboratory, one of the experiment you need to perform to pass in the practical exam for the HMT. But due to this pandemic situation, it is not happening. This is advantage for you, but we have to conduct the practicals. At least you should know what is meant by thermal conductivity, how to calculate the thermal conductivity, how to calculate the natural convection, how to calculate the heat exchanger performance, what is meant by heat pipe, critical heat flux, what is meant by critical heat flux, how to calculate that. So at least you have to know about that experiments. Okay, so that is the initial uh, thought process about the conduction of uh, practicals. Okay, so live demo I will provide you how to conduct that. Okay, how to perform the practicals, and we will finish up with the practicals. So for that, I think near about 6 to 7 experiments we have to conduct, and two experiments are based on modeling. Okay, so we will conduct 7 8 lectures, 7 8 practicals. Okay, so is there any doubt, any question? If you don't have any doubt, any question, then you just put up your roll numbers in the chat box and you can leave. Remaining student, please put up your roll numbers in the chat box and you can leave. I want to close the meeting.